Hello everyone, this is me Aavash Thapa with my friends
Reeyaz.
Aarnav.
and today we're going to perform a short presentation to see the maximum height the rocket travels using trigonometry. So Reeyaz, how are we going to measure the maximum height traveled by the rocket?
So we are going to measure the height of the rocket using the clinometer, which are going to be placed in the opposite direction towards the rocket.
So now we are going to place the clinometers exactly 9.5 meters away from the rocket. So let's start. So now that the clinometers have been put apart 9.5 meters away from the rocket, as you may already see on the right side and on the left side. So let's begin with the rocket launch. So Reeyaz, what was the maximum height traveled by the rocket?
As you can see, the rocket traveled exactly 50 degrees from the right point.
Thank you. So Aarnav, what was the maximum height traveled by the rocket from the left side?
As you can see, the maximum height traveled by the rocket from the left side was 40 degrees.
Thank you.
So now we are going to move to the calculation part where we will figure out the height using trigonometry. So now let's move on to the calculation part. The distance between two clinometer is 19 meter and the average angle are 40 degree and 50 degree. This was the clinometer in the right, which the degree was 50, and this was the calculator in the left, 40 degree. And the distance between those two clinometer was 19 meter, and the height of the clinometer was 0.8 meter, which will be added at the last to find the final height. And and this was the point where the rocket was launched, which will be denoted as h. And we can say that so now let's move on to the calculation part. The distance between two clinometer is 19 meter and the average angle are 40 degree and 50 degree. This was the clinometer at the right, which we got 50 degree, and this was the clinometer at the left, which we got 40 degree, and this was the distance between the two clinometer, which we got 19 meter, and this was the height of the clinometer, which we got 0.8 meter. Let's suppose height as h, and if we say that C and D is x, we can say that B and D is 19 minus x. Now from triangle A, B and C, we can see that tan 40 degree is equals to h by x, which and we know that tan 40 degree is equals to 0.84. After calculating, we will get h is equals to 0.84x. Now from triangle A, B and D, we can see that tan 50 is equals to h by 19 minus x. After calculating, it will be 1.91 into 19 minus x. After doing this, we got equation 1 and equation 2. Now we will be equating equation 1 and equation 2. After equating them, we will get x is equals to 11.138 meter. So now we can easily find the height by replacing the value of x, which will be 9.36 meter. Now to find the final height, we need to add the height of the clinometer, which is 0.8 meter. So the final height after adding the clinometer height and the height is 10.16 meter.
So this is it for our project. Hope you enjoyed it. So the height may not be accurate as we are just establishing the relationship between the rocket launch and trigonometry. Hope you enjoyed it. Thank you very much.